The International Space Station is humankind's laboratory orbiting Earth. At an altitude of about 400 kilometers, typically 6 astronauts and cosmonauts spend their time on the space station doing experiments on board, but also using external equipment. ASIM, a new experiment, is intended to be mounted on the outside of the International Space Station, more specifically the European laboratory module called Columbus. The Columbus module was mounted on the International Space Station in 2008. Deliveries of supplies and new equipment is done by several different kinds of spacecrafts. Here we see the Japanese HTV transfer vehicle that will be used to transfer the ASIM experiment to the International Space Station in 2015. HTV is not able to dock automatically with the space station, as is the European ATV. It has to be captured by the robotic arm and then slowly moved towards docking with the space station. When firmly docked, equipment in the payload bay can be extracted and moved on for mounting on the exterior of the space station. The robotic arm of the International Space Station has been delivered by Canada, who is also a partner in this giant science project. In order to move the instrument platform further towards the Columbus module, it is mounted on a carriage that's riding along the main boom of the International Space Station. Then, using the Dextra robot on the robotic arm, the ASIM experiment can be mounted on the external platform of the Columbus module. When mounted and firmly connected, the ASIM experiment can be remote controlled from the ground or from astronauts aboard the space station. ASIM stands for Atmosphere Space Interactions Monitor, and it will study the interaction between the atmosphere and space. One thing that will be studied is the effect of thunderstorms. It is known that thunderstorms produce lightning that strike the ground or that strike from cloud to cloud. But thunderstorms also produce what's called sprites, which are electric discharges that go from the cloud tops and into space. Typical sprites can have altitudes reaching up to about 80 kilometers, which is close to the edge of space that is usually defined as 100 kilometers above the surface of the Earth. Investigations by ASIM will try to find out what the discharges mean for the atmospheric chemistry and the atmosphere in general. In order to investigate, ASIM has several kinds of instruments: cameras, photometers, and a large X-ray and gamma-ray detector. The cameras will be used to image the sprites, the electric discharges, to see how they evolve. imaging sprites from space is much better than from the ground, since the overview from the space station gives much better opportunity to view the sprites in their entirety. The electric discharges are known to produce high energy radiation like X and gamma rays. The ASIM experiment is also equipped with a large detector that can register the X-rays and the gamma rays, the most energetic form of light that we know. X-rays and gamma rays, because of their high energy, are hard to focus. In order to register them, the instrument will use what is called a coded mask, which allows the X-ray and gamma ray radiation to pass through and create a pattern on the detector. This allows the scientists to find out where the radiation is coming from, and the detector will measure its energy. Observing from space will allow ASIM to study many other kinds of atmospheric phenomena, like hurricanes, dust storms, volcano and forest fires. The ASIM instrument is realized as a mission through the European Space Agency. The National Space Institute at the Danish Technical University provides the scientific leadership, and the Danish company TERMA the technical leadership.